So, hello everyone, I'm Scott Dutton. I work for Sykes Cottages, we're based in Chester. We've recently won the Northern Tech Award for leadership in the area. So we do quite a lot of exciting stuff. If you're interested in hearing more about Sykes, please let me know. There's a few of the team here as well. And you're welcome to come and join us. So this quote, I heard it a while back and it really stuck with me. The culture of any organisation is shaped by the worst behaviour the leader is willing to tolerate. The same is true for code bases. So if you're in the code base situation, it's going to be the culture of your code base is shaped by the worst behaviour that the CI process is willing to tolerate. So if your CI process will tolerate bad code, you're going to get bad code. So when we talk about coding standards, what do I mean? It's a convention which has been formally adopted. It's something a project will follow. It's designed to make it easier to understand, so new people coming into the team can understand code. It's something that they'll probably have had experience outside, so if they've used PSR2, for example, and your code uses PSR2, they'll have a head start on knowing what standard your code accepts. It reduces merge conflicts. I'm fed up of seeing white space conflicts in Git. It's very easy to reduce those conflicts if you have standards. And it's not just about style, so PSR2 does focus a lot on style. It's quite a lot more than style, as we'll come on to in a little while. And it makes it clear what's expected. So new people coming into the team, it's clear that whatever code they're going to produce is exactly what is acceptable by the team standards. And most importantly, it's enforced. If it's not enforced, you don't have a code standard. None of the tools work, so you have to enforce it. So why do we have standards? It increases safety, it increases compatibility, it decreases learning and understanding time. These three I actually found about any standard. So when you Google standards, these three do pop up. Having standards means I can turn up here today, plug my laptop in and just know that everything will just work, that the standards are quite formally adopted and everyone is aware of them. More specifically for code bases, it decreases conflicts. It speeds up the onboarding process because the standards that you use are widely, the standards you use should be widely known. So if you are using PSR2, for example, that is widely known. It makes it known what's expected. So in your pull requests, it's sometimes a bit intimidating if people comment on your pull request to say that it's not quite right, you need to change it. It's much easier if the CI process or the build before you even push it tells you that it's not quite right. It's a professional thing to do, so all professionals do have standards. A quote from Uncle Bob is the only way to go fast is to go clean. So having clean code does increase the velocity that you can go. And it makes the primary value of software more clear. So the primary value of software is making it easy to change. The secondary value is it actually working. It's right now. All software needs to change. Nothing stands still. So you have to make things easy to change, easy to swap in and out. Having standards does make that a lot easier. So here's some code that I found on Stack Overflow. I'm not quite sure if you can see the code. It's a function called d. It has 4 parameters, x1, y1, x2, y2. It uses a load of trigonometry. It's got 69.09 thrown in there. Who knows what that means? Because it's on Stack Overflow, I guarantee it's been copy and pasted into hundreds of code bases and just left there. So when we rewrite that a little bit, again, I'm not quite sure how much of this you can see. We now know that the random number actually relates to the square root of the Earth in miles, which is related up there. You've got the what the formula actually is, so people can look at it themselves. If there's ever a bug with it, and you had the previous one, I'd have no idea where to start with that, trying to Google what is actually wrong with that function. This one, at least, is documented what it is. It puts the x1, y1s together with and calls it a point on Earth, because having a longitude doesn't make sense without a latitude. So if they don't make sense together, just put them in a class, have that as your value object, and pass that around. So again, this code, we can still do a lot more with it. I've run out of space trying to pretty it up a little. But as you can see, it's much easier to read than that code. And you can debug it quite easy. Someone new coming into the team trying to find a bug with it is much more likely to fix the bug in a reasonable length of time than when they're on this code. So the existing tools, There's a lot of code standard tools for PHP. We're in quite a fortunate place. phpcs is probably the most widely known, widely used for coding style. So this checks that your white space is there. It can check that you've got type hints. It can check that you've got actual types if you're using PHP 7. It can check a lot of things. PHP parallel int. This checks that your syntax you're checking in doesn't have syntax errors. So there's no reason to have a syntax error in your code. It's nice and quick. Just put it in your CI process. You won't regret it. PHP Mess Detector. This one can detect all sorts of things about your code. So if it's too complex, if you're I forgot what some of the things are, but it's got a lot of checks in it. So there's 5 flags that you can pass to it. Each one of them's got a different style of checking. So it checks that all parameters are actually used and things like that. It's a very good tool. PHP magic number detection. So a little bit earlier on, we've seen that random number in the code. Nobody knew what it meant. Magic number detection will stop that going into your code. It's very easy to see for future people. A massive, massive hint on magic number detection is don't just say that the number is the word the number. So like $9 equals 9. That doesn't help anybody. Describe what the number is actually supposed to be doing, and it's much better. phpstan and phan, they're static analysis tools. These things find so many things that are wrong with your code. Passing wrong types in, passing too many arguments to a function, loads and loads of things. They're really good tools to have on there. They're quite new tools, but they're definitely worth having in your CI process. PHP Unit, so unit testing, it can output code coverage. So you've probably seen the HTML coverage. It also outputs other formats as well, like Clover. You can use that to see what total percentage you've got in your code. PHP copy and paste attack. So if you've got a class and you want to do something quite similar to what that class does, the standard way to do that is just copy that file and change a little bit. And then in 6 months' time, when there's something that affects one of them, you fix it in their one, and then there's another bug because it also affects the other one. So this stops you just random copy and paste codes. It makes you refactor and reuse your code, which is what you should be trying to do. Infection and humbug. These ones are mutation testing. So when you've got a good suite of tests, these change your code subtly. So if you've got variable 1 plus variable 2, it'll change it to variable 1 minus variable 2. Or if you're incrementing a number, it'll decrement a number, or it'll change the visibility of the method from like public to protected, see if that breaks it. If your unit tests pick it up, then you've killed the mutant, and if it doesn't, then the mutant's escaped, then you need to change your code because there's potentially a bug that's hiding in there. It's great for finding off by 1 errors. The OpenSSL bug a few years back was caused by an off by 1 error. If they had a test around it and it was covered by infection or a similar tool, that would have been spotted. And there's more. There's loads and loads of tools. We're in a very good place for tools. So after you hear about these tools, you get the conference effect. You fly into work then on the Monday morning, you try all these tools out. You then find that the problem is on your new code bases, it probably goes in okay. There's a couple of errors. You fix it. On your old code bases, you've got no chance because the error list is absolutely massive. So legacy code does present a bit of a problem with it. So does anyone know what the biggest patch for WordPress ever is? That's right, yeah. So WordPress following their own style guides. So you might laugh that it's WordPress and people joke about their code quality, but at least WordPress has a style guideline, which is probably more than your company's app at a similar time. So it found almost 89,000 errors, 83.7 were also fixable, so someone starts to manually go through and fix them. 101,000 line additions, 74,000 line deletions across 1.2 thousand files. I don't know if anyone's reviewed a pull request that big. Over 25% of all code in the whole code base was changed. 6 people across 5 months it took to get this merged. And to get it merged as well, they had to upgrade all the tooling. So phpcs had to have new features into it. They made a new code base. that had all the sniffs in the standard that they said they were going to enforce. And it was 11 megabytes big, the diff. So that is absolutely massive. And as Rob said, it was from Juliet. So I imagine that not all code bases have a hero like Juliet to clean the code up like that, but they all definitely should. So staying on this, Doom and Quake together, the original versions, are about the same size as the WordPress patch. I actually imagine that you could finish both Quake and Doom before you finished reviewing the code for this as well, because it is such a big change. So if anyone's ever tried to enforce styles retrospectively, they'll know what a huge task this is. So Juliet done a fantastic job of actually getting it merged. So legacy code. What do we mean when we say legacy code? Code without tests is the Michael Feathers definition of it. Wikipedia defines it as source code inherited from an older version of the software. I kind of define it as code not following your current standards, because you can easily change your standards. Standards do evolve over time, new things come in, and it's easy to pick these things up if you, and then when you've picked them up, your old code would be considered legacy. So when you ask your boss or whoever's setting deadlines on it, the Stilbert comic pretty much explains it. You'll ask them what they want to do about best practice and consistency, and they want it all. They want it now. It's kind of hard to deal with. At Sykes, we had meetings where we said that for new code bases, we'll definitely enforce all these things. For old code bases, we'll try and enforce these things. As Yoda says, do or do not. There's no try. Trying, it's not enforced, so they might increase a little bit for a little while, but after 2 or 3 weeks, you're back to the old standards and just getting things in because the CI process allows it. So my solution to this, I tried for quite a while to try and get these new tools to go into legacy code. It's not an easy task. There's not an easy solution for it either, so the solution that I came up with effectively is diff filtering. So you say that whatever your code is now is going to be the worst that this code's ever going to be. It's only going to get better from here. Any change you make is then enforced. So if you make a change that isn't PSR2 compliant, regardless of the rest of the project not being PSR2, that will fail your build process. So it's a 3-step process. You generate the output from the tool, so you run phpcs on your code base. You generate your diff, and then you combine the two and show only the errors that appear in both your diff and the change code. So it allows the tools to enforce only what's changed, so only what you've been changing yourself, and on a pull request level as well. So when you've checked it in, the whole pull request is checked just as the pull request. And it decouples your aspirational standard from your current standard, and they can be quite different. So you could aspire to have really clean, nice code that's well tested, but your current code base has 1% test coverage or something. So the installation's fairly easy. It's a composer library, or you can download the FAR, or you can just check out the code base and run it. It does work for other languages, so there's no composer direct requirement because it's not easy to have composer on if you're using Java, for example. So the implementation, at Sykes when we implemented it, the not enforced method, you tend to say that there's a problem with your code, it's not quite following the standards, can you please change it? The author says it's an urgent fix, he'll do it later. I do have a bet with a friend when later is. I'm not sure it's after to-dos or before to-dos. Neither have ever happened, so we'll get back to you if any of them ever do. When we enforced it, it changes it. So it comes in, the CI process says that there's an issue with the code, and suddenly a second commit comes in that just says PSR2 fixes. So there's no hassle with it all. It does appear if the computer says no, people respect it a bit more than other people trying to pick at their code. So some examples. Generating a diff, I'm not sure how you branch. Generating the diff depends on how you branch. So for the rest of the talk, we'll just think it's a short-lived feature branch, merging back to master. The syntax for this is git diff origin master. Those 3 dots at the end are vitally important. That means in this case here, so you've got the master branch that's had activity since you've branched off. The 3 dots mean find the merge base, which is this first commit here, and then diff that. So it's just this section here that's in the diff. Git diff without the 3 dots does the difference between those two there. So I'm not sure how well the colours show here, and I'm also slightly colourblind, but the bottom is the green section, so that has changed. The middle section is the removed code, and the top section is not changed code. So we're only enforcing code on these bottom lines of code here, the bottom 4 lines of code, because they're the ones that have changed, so they're the ones that people should be looking at and doing things more functionally for. So phpcs. Run your phpcs command as normal. So if you do follow PSR2, run it in PSR2. I do need the output in JSON format to parse it later on, and then you want to run it on your whole source directory. When you've got your diff from before, you run the diff filter. So vendor bin diff filter, say it's a phpcs file, say it to pass in the diff, so the diff.txt, the phpcs.json, which you've just generated, and the 100 at the end. That means 100% of your pull request has to be covered by phpcs standards of PSR2. It does default to 100, so if you ignore the 100, it is the same thing. If you need to use this in your CI process, you do need to append or true at the end of this command here, the first command, because if that fails, you need to just carry on as normal. So the or true says it's effectively false, and then or true. So the CI process doesn't stop. The diff filter will exit status 1 if less than 100% of the code conforms to it. phpmd, so if we're generating a diff for phpmd, again we do the same thing. So we run it with the XML format across the source code base, and then clean code. So clean code is one of the standards that's in phpmd. They've got plenty of other standards. The phpmd website does have a good description of what those are, so agree with your teams which ones you want to enforce. Again, you call diff filter, this time with a different flag. So it was phpcs, now it's phpmd. Passing your diff in, passing in the output from the top command, and this time we're only going 90%. It's configurable because the code bases weren't designed at the time for these sort of tools, so sometimes it's a bit hard if you're trying to enforce 100% because it's a big refactor. So again, agree with your teams how much you want to try and enforce. Same as before, so you need the phpmd will fail if it finds any error. You need it to not do that, and you need to pass just of it to my diff filter. php unit. So we do this on quite a few of our code bases now. You've got you run your php unit command with your coverage in the Clover format. Clover is the Atlassian format, so it's well supported by quite a lot of tools. And then again, you just say it's a php unit file, passing your diff, passing your Clover, and 90 is 90%. So this one will fail if less than 90% of the code covered has a test on it. As Beyonce probably once said, if you like it, then you should have put a test on it. This is exactly what this command does. So php unit as well, it's sometimes hard to get the code coverage. So in this case here, it's very good to say that you're documenting it because you've got the 90% you've got to get. So if you're documenting it to say you can't test this because you can't test exit, it's documented why that hasn't got a test around it. Someone might come along later and say use a different extension, and then you can test your exit. But then that's the conversation you have at the time. But at least you can have that conversation because it's documented why you missed the code coverage in the first place. So it is okay to turn the code coverage off for certain methods and classes as long as it's documented. That will be checked in the pull review process when the team go to look at it as well. So the change over time. We've had this implemented at the Sykes in most of our code bases now for about a year. It's not in quite all of the code bases yet, but in the code base it's in, we've dropped about 40% of PSR2 errors in a year of having it. So all of the code that's changing is now PSR2 compliant. If you haven't touched the code, it's still not PSR2 compliant. The average complexity has dropped from about 15 to about 12 in methods. So again, it's going in the right direction. This is code that's never been looked at before in a complexity way or a PSR2 way. So it's all pushing it towards a standardized direction. And we've dropped some diff filters altogether. So the diff filter should be there as sort of your last resort. You should be trying to run the tools without the diff filter. Only if the diff filter throws a load of errors, you need to try and diff filter it down. Also check that it's not just throwing a load of errors because you've misconfigured it. So that is a top tip. But periodically review, see if you still need it. Run it without the diff filter, see how many errors it does throw up. You'd be surprised at how many errors you do close down over time. Because you're just doing it on your change code basis, it's relatively low risk because you're already in that bit of code, so you know what it's supposed to be doing. So when you test it, you know if you've broken anything because you're actually there changing the code anyway. So when I was searching for this, I did come across a lot of other solutions to the problem. The first one is just fix the errors. This is what Juliet did in the WordPress example. It does take a while. It is truly the best way. There's a lot of upfront time to try and fix it. It's going to be a bit of a hard pull request to get merged, but it is definitely the best. The other way is do one directory at a time. So agree that you've got a certain directory in your project and you want to do that one this week. So a Tidy Friday or something. I don't know if you guys do Tidy Fridays where you just try and clean code in one section. Fix all of them and then just enforce that one directory. Next week enforce another one and so on until you get through it all. So that is the same as fixing the errors but just over a longer period of time. It's good for incremental improvement so you can see how much of it you've actually improved on. Check in the full output from the tool. So if you check out the entire report from the tools, every time you do a change, it's a manual step each time to commit the difference, but you can see that there's red lines on that commit all the time. It should never be a green line saying you've introduced a new error. That can be part of your CI process. You can do something clever where you build pipelines to automatically reject that. You can install it as a Git hook if running it's difficult. So before you even commit it, Git will run it in, check it in itself. Git's pretty clever with things like that, so you can easily do that. The other way, which quite a lot of people do, it seems, is have someone assigned as quality control. So have someone on the pull request itself to try and review the code to say that this does need a test on it or this isn't quite right. It's basically the try option. It's a little bit better because someone's dedicated to it, but it'll catch a lot of errors and it'll just be expensive. That people are there to do proper work, not just try and do things that tools can do. If you can offload any of your work to a tool, then definitely offload it to a tool. It's more consistent over time. So the requirements for success. You need to agree with your team what standards you need to follow. You can't just, because it's quite old code, you can't just say that you want to follow all of this now. We did make that mistake. We tried to enforce literally everything at the first instance. There was mass panic for 45 minutes because no pull request was merged and there was just pages of errors that wouldn't go away. So increment it slowly, do one tool at a time or do one level of tool at a time. So if you're doing phpmd or phpstan, they've got configurable levels. Just do the lowest level first and then gradually get higher. You need to be flexible with the standards. So some of the old code can't actually use all the new standards. So if you're using CodeIgniter, you can't use PSR2, but you can use something close, which we'll come on to in a minute. Boy Scout attitudes. So the Boy Scouts of America have a motto of always leave the campsite cleaner than how you found it. You need to have the same sort of attitudes in your workplace of always wanting to leave the code base better than how you found it. People have to want to make things better. And knowing it's okay to turn the checks off. So sometimes it's the right thing to do to turn it off, but it's, again, a group decision. We've got a bit in the, it checks the Git commits, and if it says skip build, then it will just skip the build. People, again, review this, but sometimes you do need to turn them off. It's about being pragmatic. Again, this one's a bit hard. If you've committed some code, it's gone live, you've fixed a load of PSR2 errors, you then revert it. The revert obviously brings back a load of PSR2 errors in, so your build won't pass, and you need to be able to turn it off for things like that. And as we had before with the PHP Unit example, you can disable the checks in line, but just leave a comment as to why. Someone else will come along and solve that problem. If they know what the problem is, they'll be able to solve it. So when I said be flexible with standards, this is quite often quoted. It isn't adding new standards, it's just using what you can use. So CodeIgniter can't use PSR2, but you can use something pretty close. PSR2 also predates PHP 7, so if you want to use the namespace with multiple checks, you can't. So this example here, if you've ever used this syntax, it's quite nice. So this imports namespace class 1 and namespace class 2 in a nice, easy-to-use way. PSR2 doesn't like this because it says you can only have one use per statement. So what we do is just turn off the use declaration, so PSR2, but take away that one rule. It's documented by, and you can, again, expand this if you've got other checks. So if you do require things like type hints to be passed, you can also add this to here, and again, it's just checked in with the project, so anyone on the team can see why. They can put a pull request in if they think it needs to change, and it just causes a discussion. After you've implemented all of these, you're going to notice that your CI crawls because it's over a huge number of files. Your legacy code base is going to be quite big, so there's going to be like hundreds of files in there. These tools are designed for a smaller number of files because they're designed for a more modern way, but they still do give benefit in your old code bases. So removing your debug environment is top tip for this. Xdebug is an absolutely fantastic tool, but you don't need it in your CI process unless you're generating code coverage. So on your own CI server, run the command php dismod to disable it, or php7 dismod if you've got 2 versions of PHP on there. Using Travis, just remove the xdebug.ini file. As an example, this was ran on phpmd. So it's quite a big code base where they've got a lot of files, and it's probably a similar sort of structure, I guess, to some of the older projects. So just removing Xdebug, sorry, you get down to about a third of the time running. So it does make it a lot faster. You only need this once for when you're doing your code coverage. If you do it like multiple environments, just turn it off for all the others. Only running the process for change files. If you're only caring about the lines that have changed, you only care about the files that have changed. So again, this is running on phpmd. Running the whole phpcs took 277 seconds. Running it without Xdebug took 105. And running it on only the files that have changed took 6 seconds. So it's a massive performance increase. You can run it with this phpcs file list equals file.txt. When you just get that from Git, Git will tell you which files have changed, and you pass that straight through to phpcs. And that will just run it for the single files. It also depends on the tool, because some of the tools do need more files to run on. So if you're doing phpmd, you can't just run it on the one file because it's going to miss other files. If you run it on phpstan, it won't be able to import all the other definitions. So if you break an interface, for example, and you're not saying that interface is there, it's just going to throw errors. So there's no speed up for these apart from just using Xdebug. And running in the order, fastest, slowest, you can have quite a few things in your CI process at this point. There's nothing more infuriating than job 1 taking 8 seconds, job 2 taking 5 minutes, job 3 taking 31 seconds, getting to job 4, which took 3 seconds, and it failed early on because you've missed one space. That could have been told you straight away in 3 seconds' time. There's no reason to have that 5-minute job in between or any of the others, so just order it in what is generally the fastest, slowest. And run each tool once, keep the output if you need it. If you're running it on multiple versions of PHP, it's going to be phpcs OK across all of them. You don't need to carry on running it. If you're running your unit tests, just turn off your code coverage. Just run it once on the environment you want to have your code coverage on to send to somewhere else. And allow your build to be run locally. It's really annoying having to try and work out what the build process does. So Travis is a fantastic tool, but everyone just puts the lines in the Travis file. So you then got to work out what the YAML file is, take out each of the little bits. Just have Travis set up its environment. The Travis.yaml should set up its environment it needs, and then just call the build file, the same build file that you'll run locally. So people can run it without even having to send it to the CI server. Your CI server should be there for when you're happy that everything's working. You can put that on Git hooks if you need to. You can have them automatically installed by Composer again if you need to. Grumpy is another great tool. I don't know if anyone uses it, but that runs the checks automatically as well, and that won't let you commit without it. And it gives you a big bearded fellow that looks angry at you if you have committed something you shouldn't have done. The last one, I got a bit of mixed feedback on this. I wrote a plugin for PHP Unit. If you pass in the coverage of your previous runs, the diff that you've done in this time, and a little fuzziness filter to try and help match on some things, you can actually just work out what tests are needed. So if you change one file, that one file probably only has one test around it or a couple of tests around it. This automatically works out, so it's like a very smart version of filter. So when you run your PHP unit, it'll ignore any class that hasn't changed, and it just runs those like 1 or 2 tests, and they're probably a lot faster than running your whole test suite. Because if you have new code, your test suite will probably run in maybe half a second. You'd have old code. I was in a workshop yesterday where someone said that their build took 6 months to run. Most people's isn't that long. Most people's is probably less than an hour, but it's still a considerable amount of time. It does work. We've not properly used this at Sykes yet, but it does seem to work. And it's not just for PHP. So if you're using other languages, diff filter can just take in the output from the command, the diff itself, and then complain about the differences. If there's a report type that isn't supported, let me know. But it's Pylint supported, Jacoco, check style, they're all quite common to see. There's other things as well, like Buddy, which is a magic number detector for JavaScript, ESLint supported. So it's not just your PHP that you should be trying to improve. It should be your JavaScript, it should be your CSS, it should be anything you can, enforce. And remember that the standards defined in the code base are the minimum acceptable. So from the quote at the very start, it's whatever the CI process enforces is the minimum that's acceptable. Your standards might be higher than builds. Just go higher. You shouldn't be dragged down to the minimum. You should always try and improve the code. Obvious ones that go against this are if you're going to change literally everything, the entire project, change the entire structure. That's probably not going to be accepted by anyone. But for general things, it's quite easy to do. One more thing with this. If you're committing to open source projects, the CI process itself doesn't have to run it. You can run it locally yourself. So if you want to make sure that you have code coverage on the bits that you're submitting, so if you want to say you've got a unit test on it, you can run this locally and then submit it to the open source project. They won't run it themselves, but at least you'll know that all of your bit is well tested, well covered, well written. It's a nice thing to do as well. So is there any questions? No? Lorna?
You've obviously put a lot of work into the tools that you're describing. Did you do that all in one go, or is this something you sort of built up over time?
Built up over time, definitely. We started with 3 of the ones listed. The phpcs, the magic number detection, because we had loads of magic numbers. And then gradually, it's just because the tool that I've built, you can put a new standard in quite easy. It gradually built up over time. I found out quite a lot of different tools as well through having this. So I forgot what the URL is, but there's a URL which shows you a lot of PHP quality tools and not just PHP, it's like other ones. So I've got round through them, built them locally, found their report formats and put them back in. So then they're supported as well. Any other questions? Yep.
Is some of you going to put your slides online?
Yeah, they're going to be online, definitely. I'll get them on straight after this. Any other questions? Yep.
Not really a question, but another way of doing it is enabling, enable the rules, see how bad the problem is, then narrow the problem scope, and then maybe do individual cases just to fix specific rules.
Yep.
And mixing style changes in with the actual config, the actual code changes.
Yeah, we did think about that, and that was the one where it was like doing a directory at a time.
Doing the whole code base at the time in that case.
Yeah, we've got a lot of big code bases. Legacy code bases do tend to go massive. We had one code base last year that was 1.3 million lines big. I think only about 60,000 lines of that was actually used, but knowing which 60,000 lines is near impossible. One of the guys here built something to go through the logs and try and work out which code was hit, and then I think we reduced it by 500,000 lines of code just by going through the logs and trying to parse which lines were actually used, which files were actually used. So it was a good thing to do, but for old code, you do have to spend quite a lot of time to try and get it normal. If you do have a few errors, it's definitely better fixing them. It's when you've got a mass amount of errors that you need to run these tools, or if you want to enforce code coverage on a pull request. I don't think there's anything else out there that does it on a pull request level. It's always on the code base level, so you can say like 60% of the code base has to be covered, but nothing about your individual pull request.
We found that Google coding is very good for getting people to do the lacking
Okay, yeah. Cool. Yeah.
Obviously, PHP code sniffing can give you a lot of intelligence about the lack of quality in code base, perhaps.
Yeah.
What about the kind of system tool that comes with it, CDF? Is that something you recommend on a...
Yeah, that is good. So in the WordPress example, there was still 7,000 lines of code, or 7,000 errors that it found. So it's definitely worth doing. You can, if you're going to do that, do it in one big pull request to start with, and then increase after. Don't do it like per file, because you end up with a lot of irrelevant stuff in your pull requests then. But it is a very good tool. Is it CS Fixer? Yeah, it's a very good tool. So if you do want to enforce standards, definitely run that tool first. Yep.
You mentioned that you've reduced your code complexity score by what looked like a fair margin.
Yeah.
But how did you get on right at the start of that process? Because different people have had complexity in different ways, and some people I've spoken to haven't always found it obvious for how to reduce the complexity of their code.
phpmd has that built in, so if you're adding complexity to it and it goes over a certain threshold, I'm not quite sure what the threshold is in phpmd, but it is quite low, it will just fail the build and say it's too complex. People can then ask why it's too complex, but it is normally because you've nested it quite far and you can just refactor its functions. There was definitely an education piece to start with, but it's... yeah. The guys at Sykes know I'm pretty picky on pull requests at times, so it's definitely helped with that sort of thing. Any other questions? No? Well, thank you very much for listening. Sorry? Okay.